This video is on using a factor tree to find the square root of a number. So first thing we need to obviously understand is what is the square root of a number. So let's just have a look at a couple of examples here. Some square root numbers, the square root of some numbers, you would already know off by heart, and that helps. So when we think of the square root of 36, what you are supposed to be thinking of is there is a number that multiplied by itself will give me 36. So that's what the brain starts thinking. And we know that if we take 6 and we multiply it by 6, so 6 times itself, we get 36. And that is the square root of 36. So the number that multiplies by itself that gives me 36 is 6. So we can say that the square root of 36 is 6. So it's the opposite operation, or the inverse operation for squaring a number. So that's what square rooting a number is, the inverse operation. So when I take 6 and I square it, which I've done over here, I'll get 36. And when I'm square rooting it, instead of squaring, I'm thinking what number multiplied by itself gives me that 36. Same thing over here with 81. Okay, it's the inverse operation of squaring. So I'm thinking what number multiplied by itself gives me 81, and it's where it pays to know your times tables. We know that 9 times by itself, multiplied by itself, will give me 81. So over here I'm squaring, but when I'm square rooting, okay, it's the inverse operation, I'm thinking what number do I multiply by itself to give 81? So that is 9. But what do I do when we get to bigger numbers, like the square root of 324? That's a square root that I do not know off by heart. And that's when we've got another method that we could use to find the square root of a bigger number without using my calculator. So let's go on and have a look at 324. How can a factor tree help? Well, I think firstly let's get our factor tree drawn and then look at how we can use it. So I've got to find two numbers that multiply to give 324. I hope you can see that 4, if I look at 324, 4 goes into 32. So knowledge of your timetables will be important. 4 goes into 32 8 times. So I'm already looking at that. And then 4 goes into 4 exactly once. So it turns out that 4 times 81 is 324. So I can break down 324 into the product of 4 and 81. And 4 and 81 are both not prime numbers. So I'm going to keep going. 4 I can break into two prime numbers. It's 2 times 2, and 81 I can break into the prime numbers into 9 times 9. Okay, so we've got prime numbers over with the 2 and the 2, but the 9s I have to keep going. I know that 9 is 3 times 3, and this 9 I can do the same thing and turn it into 3 times 3. And now I do have prime numbers all the way. So we've got 3, 3, and 3. So this is what we call the prime factorization of 324. Oops, where'd that go? Now, when I get down to the prime factors of 324, that's when I need to remind myself that when I'm finding the square root of a number, I'm looking for a number. What number multiplied by itself gives me 324? And that's when I can look at these are highlighted prime factors, and I can break them into two separate groups so that both groups are the same. So I could take this first 2, put it here, and this second 2 and put it over there. Then I could take, sorry, it's not very clear. Then I could take this first 3 and put it over here, and the second 3 and put it over there. Take this 3 and put it over here, and this last 3 and put it over there. And the reason why I'm doing that and putting the same numbers in each group is that I want to think of a number times by the same number. So in these two green circles, I actually want to end up with the exact same number. So when I get my prime factorization, I'm going to split those numbers in groups of 2. So when I see 2 2s, I'll put one in the first circle and one in the second, so that I end up with a number multiplied by itself that gives me 324. I can't do that in my head, but once I've got all the prime factors, then I can look at them and split them into 2 groups that are the same. So it turns out that 2 times 3 times 3 times 2 times 3 times 3 equals 324 using my prime factors. And I want to remind you that when we get to the bottom of the factor tree, these numbers are all joined, if you had forgotten, by multiplication, because these are the prime factors that multiply to give 324. So if 324 equals 2 times 3 times 3 times 2 times 3 times 3, then the square root of 24, well, that just is asking what number multiplied by itself gives me 324. Well, that's just one of these 2 groups. That would be 2 times 3 times 3, and 2 times 3 is 6, and 6 times 3 is 18. So the square root of 324 is 18. Now, if you're happy with that, you can have a look at this next example and attempt it without me. Okay. If you're a little confused still, then you can sit through and watch this next example, and hopefully you'll then know what to do. So we're going to try and square root 784, and we're going to draw a factor tree. So we can see once again we've got 784 and 4. So I'm going to divide. I can see that 4 goes into 784. I'm going to divide that by 4. 4 goes into 7 once, remainder 3. 4 into 38 goes 9 times, remainder 2, because that's 36. And 4 into 24 goes 6 times. So I know that 724 is 4 times 196. Now I've got to find a factor of 196. So I might try 4 again. 4 goes into 19 4 times, remainder 3. And 4 into 36 goes 9 times. So it turns out that 196 is 4 times 49. Now, none of those numbers at the bottom of the factor tree are prime factors, so I have to keep going. So I'm going to break 4 into 2 times 2, and this 4 into 2 times 2, and this 49 into 7 times 7. So now I have prime factor, prime factor, prime factor, prime factor, prime factor, prime factor, and I'm trying to find the square root of 784, and that means I'm looking for some number multiplied by itself will give me 784. So I need to split all these numbers evenly across these 2 circles. So if I put this 2 in here, and this other 2 will go over here. If I want to put this 2 here, must go here, and this 2 would go over here. This 7 must go here, and this 7 would go over here. And as you can see, I've got the exact same numbers being multiplied in both circles. So when we think of what is the square root of a number, so we're trying to square root 784, I think what number multiplied itself gives me 784? Well, my factor trees help me to see that the number that I multiply by itself to get 784 is 2 times 2 times 7. Well, 2 2s are 4, and 4 7s are 28. So that is the square root of 784. So, reminders for you, make sure your factor tree is clear. Okay, nice setting out is important, and highlight the prime factors at the bottom of the factor tree so you don't miss any. And I think this line here is very important to remember. This one over here is that you're looking for the number under the square root sign must be written as another number multiplied by itself. So you're trying to find that number under the square root sign equals what number times by the same number again, and that'll help you to find your square root.